Okay, so we are expected to solve this question. The requirement is that we are to find the perimeter of the shaded region. Now let me state that here. Required perimeter is going to be equal to this length. So BC plus this length XC plus BX. Now you need to find each of this and then add it up, and that would give you the solution. Now we have been given the arc length. So AB is given. What is that? 15. And OA is the radii. So OA is equal to OC is equal to 6 units. That is also is given. Now what I plan to do is I would want to find out this angle. Let me take this as theta. Now AB is the arc length, right? So there is a formula which states that L is equal to R times theta. Now L is the length of the arc, length of AB. Now theta is the sector angle, and R is the radii of the circle. So substituting it, L is 15 units, R is 6 units, and theta is what is required. So from here theta is equal to 15 over 6. 3 can divide here 2 times, 3 can divide here 5 times. So theta is equal to 5 over 2. That is going to be 2.5 radian. So this is calculated in radian measure. Having got theta, what I plan to do is I would want to get this angle, which I can state it as theta 1. Now since this being a semicircle, theta plus theta 1 is going to be equal to 180 degrees. We need theta 1. So theta 1 is equal to 180 minus theta. Now I'm not going to use degree measure, so I'll take it as pi, radian measure. So pi minus theta will give me theta 1. Now what is pi? Pi is 3.14 and my theta is 2.5. So if you were to perform that substitution and subtract, this is going to be approximately, let me just show you the 3.14 and 2.5. So if you were to subtract it, this would be 4, and you carry out 1, that's going to be 6 there, right? You will get 11. From 11 you take away 5, you will get 6, and it's going to be 0.64. Now I'm just taking it for 2 digits, 2 decimal places after the decimal point. So this is going to be 0.64. This is my theta 1. Theta 1 is 0.64. Fair enough. Now what I wish to do is I will just draw the diagram and show it to you. So this is 90 degree. This is my theta 1. This is my BX. Right. So now this is OB. Now OB is 6 units. I want to get BX. So this is my opposite side. So use the sine theta formula. So sine theta 1 in this case is opposite side divided by hypotenuse, which is equal to BX over hypotenuse is 6. So I've got sine of 0.64 is equal to BX over 6. So therefore BX is equal to 6 times sine of 0.64. This is what we have got here. Now let me rewrite that. So BX is equal to 6 times sine of 0.64. Now use your calculator, and this is going to be approximately 3.58. If you use your calculator and find this out, this value would be obtained. So now I've got bx. Now go over here. Now what do you see? This is actually a Pythagoras triangle. In other words, I can apply Pythagoras theorem to get OX. So let me draw the triangle. It's a 90-degree triangle. So this is 90, B is there, X is here, O is here, this is 6. This point is 3.58. Now I want to calculate OX. So OX squared plus BX squared is equal to OB squared. So OX squared is OB squared negative BX squared. OB squared is 36. I will write that as 6 squared. BX is 3.58 squared. Right here you can use a calculator. So I've got OX squared is equal to 36 negative 3.58 squared. That's approximately 12.81. So OX is going to be, so you take the square root of this. If you take the square root of this, OX is approximately 4.81. Now whatever the unit they are giving you, you can add that unit. Since I see that it's given in CMs, you can just place CM there and CM to all other values that you have extracted. So OX is got. Now let me go back to the figure. So this point is 4.81. 4.81. Now you need to get XC. So what is XC? So therefore XC is equal to, from OC you subtract OX. But what is OC? OC is 6 units. From 6 you subtract 4.81. And that one would give you 1.19 cm. So this is my XC. Okay, so I've got XC. Let me go back to the figure. Now this arc length is got. It's given actually. AB is 15 units, but AC is not there. We can calculate AC. Now the circumference of circle as a formula, what is r? 2 pi r, but we are given the semicircle, right? So therefore for a semicircle circumference, that's going to be 2 pi r divided by 2, which is going to be pi times r. Now you can take pi to be as 3.14 and multiplied by 6. So this is, because r is 6 units, so 6 4s are 24, 2, 8 and 6 3s are 18. So this is what you have got for the semicircle. So therefore the arc of BC, so BC is it has to be obtained. So BC is going to be equal to, the total arc is 18.84 minus 15. Why 15? I need to take away this part out. So what would that be? Let me show that here. 18.84, 15, so is going to be 3.84. So this is equal to 3.84 cm. So I have got everything I need. So I've got BC, I've got XC, and what else? I have got also BX. BX has already been obtained. So BX is over here. So therefore required, I just want to use the space, required perimeter is equal to BX, right? This part BX plus XC, this part plus BC. So let's add them all. So this is 3.58 plus XC is 1.19 plus BC is 3.84 over here, right? 3.84. So you add them, what do you get? 3.58, 3.84. This is 12, 1, 13, 14, 1, 6, 7. And then you got 1.19, 9, 11, 1, 6 and 8. So this is an approximate value. So this is approximately 8.61 cm. So if you are placing one more digit here, this would become 8.62 cm. So you need to watch the requirement, what they are asking you, whether for 3 digits or for 2 digits, and based on that you can actually include the number of digits. So that is the end of this question. We move on to the next one.